Good morning. My name is Mr. Irwin, and today is Camo Day. So that's why I have a hat on, and that's why I'm all dressed up in camouflage, if you're wondering. But today we are going to take our Unit 2 test over motion. Most of this is relatively straightforward. We have done things just like this in the past, so I just want you to kick back. I want you to take a deep breath. I want you to relax and try to think about all of the things that we've done in class already. All right, let us begin. Here is an example of the test. In front of you, you have your first page. Make sure that you write your first and last name up here. Make sure that you write the date and the period. Thank you. And let us begin. Again, it's the Unit 2 Science test. Follow along with me as I read aloud. You want to determine how wheel size affects the distance of a bike. You are given 4 bikes with different wheel sizes. All of the bikes are the exact same except the wheels. You are allowed to pedal your bike on the road with parent supervision. Number 1. The first step is to think of the question for this test and write it down on the lines below. So as you know, the scientific method states that the first step is to make observations and to write a question. Now what I want you to do is I want you to think of this situation here where you have a bike and or a group of bikes, 4 bikes, and I want you to think about what question are we trying to answer? And that's what I want you to write down here on the line, just like we did in class. We had examples with the go-kart project, and we had to come up with a question that was up there on the board. I want you to think about that with this situation and write your question here. I'll give you a second to do that. If you need more time, just push pause. Okay, number 2. We are going to think about the example situation at the top, and we are going to write a hypothesis. What is a hypothesis for this example? Now, again, you're going to think of the answer or a possible answer to your question here, and that is what you're going to write here. What is the possible answer to your question? Number 3, name the independent and the dependent and constant variables for our situation up here, the bike. What things or what thing do you think will change? How are you going to measure that? What will be the results? And then on the back, think about what things will stay constant or the same in your experiment. Give you a second to go ahead and put down your answers. You can always pause if you need extra time. Good. Next, take a look at number 4. What type of data would you collect for this example? Quantitative or qualitative data? Write your answer on the line. For question 5, I want you to think about the entire scientific method. How will you design an experiment to test the wheel size of a bike? What would you do first? What would you do second, third, and so on? And how would you know if you can answer the question to your hypothesis or not? Always go back to your hypothesis and make sure that you remember to fill in what or how you would know that you achieved your hypothesis. What does your data tell you about wheel size of your bike? And write down your results down here. I'll give you some time to do that. Just hit pause. You're going to need time. And let's take a look at the next page. Here we have 4 graphs for problems 6, 7, 8, and 9. For each graph, I want you to look at the lines and then describe the motion. We did problems exactly like this in class. So think about the study guide, think about the motion of what's going on here, and write down your answers below the graphs for each question. So if you have a line going like this, question 6, what does that mean? Write your answer down in this white space down here. Same thing for problem 7. If you have a line going right here across, write your answer of what you think it means down in the box. Question 8. What does this type of line represent? If you're not sure about spelling, that's fine. Just spell it the best way you know how, or think of another way of saying it. Question 9. What if you have a line go this direction and then goes in this direction? Write your answer down here. Okay. Again, if you need more time, just hit pause. Okay, we're going to look at the back now. We have some problems that I will read aloud for questions 10 through 13. And follow along with me. And I would say that you could, if you choose, to circle motions that are happening in each scenario. It might give you a clue. Okay? So let's look at question 10. You are to sketch a graph that represents someone driving to McDonald's for lunch, eating for 15 minutes, and then driving home. So for this graph, you're going to have 3 different lines. Give you that as a clue. You will draw your graph down here. Just think about what we did in class. We had some example problems exactly like this. Think it through, and let's go on to number 11. Number 11, sketch a graph where someone is driving on a country road slowly and then gets on the highway and drives much faster. You can draw your graph here. For problem 12, you are to sketch a graph that shows someone walking slowly, stops to get on a bike, and then rides away quickly. So there's 3 things going on in your graph here. Just a little clue. Problem 13. You are to sketch a graph where someone is accelerating from a red light and then gets stopped by a train. So what are the actions here? Well, accelerating and then stopping by a train. All right, very good. Again, if you need more time, just hit pause and take as much time as you need. But for now, I will move on. Let's look at the vocabulary section here. And that would be the next part. We have written response questions. I will read these aloud for you. For problem number 14, to slow down. Write your answer on the line. Number 15, the ability to do work or cause change. 16, energy from motion. 'Next question, push or pull. Write your answer on the line. Push or pull. Number 18, a force that prevents an object from moving when a force is applied. I'm going to move it up to the matching section now. So, press this for you so you can see all of both sides here. You have your words over here, you have the definitions over here. And what I'm going to do is I'm just simply going to read these over here. I'll read all of these together, and then you can draw lines to the letters if you would like. However, I would like you to make sure that you go back and write down the letters that go along with the words. Hello, come on in. I'm right now reading aloud this test and I'm taping it, so I'm going to kind of keep moving forward. We have acceleration, momentum, friction, motion, inertia. Now, think of the words. Okay, now we're going to look at the definitions here. First possibility could be the tendency of an object to resist change in motion. B, a measure of how hard it is to stop moving an object. Depends on mass and speed. Remember, M, measure. That might be a clue. C, a force that opposes motion between two surfaces that are touching. D, a change in position measured by distance or time. E, a change in speed or direction of an object. Speeds up, slows down, or change direction. All right, take a deep breath. You're doing fine. Now the multiple choice. Simply circle the letter that goes along with the definition. A weight hanging from a single point that's able to pivot. Is that friction, pendulum, momentum, velocity? If I'm moving too fast, just pause it. And then turn your attention to the back. The last page. You're almost done. All right. At the top. A pull to the center of an object. Do you believe it's A, gravity, B, velocity, C, friction, or D, energy? Number 6. Tells the speed and direction of a moving object. Do you believe it would be A, pendulum, B, friction, C, gravity, or D, velocity? Okay. Next, to speed up. Do you believe it's acceleration, accelerate, velocity, or decelerate? Eight, a series of steps that repeats. A, gravity, B, speed, C, cycle, D, force. All right, you're almost done. We have true and false questions. Your job is to bubble in the correct answer. For each, check to see if the definition goes along with the word. If you think it's true, bubble in true. If you think it's false, bubble in false. So, let's look at number 9. Distance divided by time. Do you believe it's cycle? If so, you'd mark true. If you do not believe it goes along with it, you'd mark false. Okay, next. A force due to roughness of two surfaces. Do you think that's rolling friction? If so, you'd mark true. If you do not believe it is rolling friction, then you would mark false. Take your best choice, and let's look at the next question. A force between the surface of a round object that keeps the round object from sliding. Do you believe that's rolling friction? If so, you'd mark true. If you disagree, you'd mark false. Last one. Energy due to condition, elastic, chemical, or position. That would be like gravitational. Is that potential energy? If so, mark true. If you disagree, mark false. All right, I think you did a fantastic job. Thank you very much for trying your very, very best. And at this time, double check, make sure that you turned in your paper. And I will see you next time. Have a great day. Yay!